Hello friends, good morning. Welcome to ASTRA 2022 program presented by AKKA IAS Academy. In this particular video, I'll be discussing few of the basic concepts based upon number system. So let's begin. Number system. Okay. In this particular topic, what kind of question you may be expecting is, see, if at all they will be giving a series of number and they will ask you to find the total sum of the number. Say for example 1 plus 2 plus 3 plus till 100. Okay, the sum goes on. So what is the total sum of these numbers? Okay, and they will be asking you to convert a decimal into fraction. Okay, so see, these are the some examples what type of questions you may be expecting in this number system here. So before dealing with number system, I'll try to explain the basic concepts. Okay, so what are numbers, how are they classified? Okay, what do you mean by real number or imaginary number? What are rational numbers or irrational numbers? Okay, so first I'll try to explain all those and then we shall deal with the concept, that is divisibility rule, and sum of odd number series or sum of even number series or sum of the series, or converting the decimal into fraction ones. So what are the rules for all these questions? I'll be dealing in the later stage. Okay, so numbers, see here, number actually they are classified into real number and imaginary number. Okay, so real number is nothing but a normal number. Okay, normal numbers what we all deal with in day-to-day life, they are known as normal number. And imaginary number means, actually, see, if at all the question asks root I, okay, root I is actually -1. Okay, so if at all this I is presented, then it is called as imaginary numbers here. Okay, so again this real number is again divided into rational numbers and irrational numbers. So see here, rational numbers means, actually, see, for example, say I'll say root 9. Okay, what is the answer for root 9? Actually 3 is the root 9 for answer for this. Okay, so 3 into 3, that is 9 here, so we will be writing as root 9. Okay, so then the answer will be 3 here. See, for example, root 2 is there, so the answer for that will be 1.4142, and it goes on like this, right? There is endless here for this number. Okay, so such kind of numbers are known as irrational numbers, and these kind of numbers are known as rational numbers. Say for example, square root of 141. So what is the answer for this? Square root of 141 is 12. Okay, so this is rational number here. Okay, so next concept, this rational number again it is divided into integers and fractions. So integers are nothing but 1, 2, 3, it goes on like this. Okay, so fraction is nothing but it will be written like this, 1 by 3, 3 by 7. Okay, it goes on like this. These are known as integers and fractions. In rational numbers, it is divided into integers and fractions here. Okay, so again in integer, see, again in integer it can be divided here. It can be divided into positive integer and negative integer. So positive integer means 1, 2, 3, it goes on like this, and negative integer means -1, -2, -3, it goes on like this. Okay, integers again can be classified into positive integers as well as negative integers. So these positive integers here, again it can be classified into natural numbers, that is 1, 2, 3, these are called as natural numbers, and not in unnatural numbers. Okay, on whole numbers, not unnatural numbers, whole numbers. Whole numbers means if at all the number series starts with 0, 1, 2, okay, it should start with 0, then only it is called as whole number. Okay, natural number and whole numbers. Integers can be classified into natural and whole numbers here. See again this natural numbers, again it can be classified into even number. and odd numbers, okay, prime numbers and composite numbers. Okay, this natural number can be classified into 4 types: even, odd, prime and composite. So even number means actually 2, 4, 6, 8, these are called as even numbers. Odd number means actually 1, 3, 5, 7, it goes on like this. Okay, so prime number means, we know in the basic concept I have dealt with. What do you mean by prime numbers? 3, 5, 7, this goes on like this. Okay, composite number means a number which have more than 2 factors. Okay, has a number having more than 2 factors are known as composite numbers. Say for example 15. So what are the factors for 15? 3 into 5 and 5 into 3 and 15 into 1 and 1 into 15. So these are the factors for 15 here. So more than 2 factors. See, 3, 5, 15 and 1. Yes or no? So these are the 4 factors for 15 here. Hence 15 is a composite number here. Okay, so these are the few basic points what you need not to remember for the examination sake, but if at all you know, it's better here. Okay, if for example the question may start with a rational number, okay, then a rational number means it actually includes both integers as well as fractions. So that concept, if at all you understand, then it is better here. Okay, so in the next page I'll be dealing with the divisibility rule here. Okay, so divisibility rule. So any small number can be identified, right? Say for example 15. So this can be divided in 3 or 5. We know that, right? 3 into 5 is 15 and 5 into 3 is also 15 here. Yes or no? Hence the 15 number can be divided by 3 as well as 5. Small numbers, for smaller numbers we can say it is actually easier. Say for example 1652. Okay, 1652, this can be divided by 2. How? What is the rule for that divisibility rule? I'll be explaining one with an example here. Okay, so for example, see friends, 5 and 10 I'll be taking in the first case, 5 and 10. Okay, so the rule is any number, okay, any number. See friends, actually if you know this divisibility rule, it becomes handy while solving the problems. Okay, so try to remember this formula. Okay, try to remember the rule, not the formula. Try to remember the rule. So which number goes with which number? So for the divisibility rule of 5 and 10 is any number, okay, the last digit of that number, okay, it should end with either 5 or 0. Okay, then that number is divisible by either 5 or 10. Okay, say for example 105. Okay, it is divisible by 5 because last number ends with 5 here. Yes or no? Say for example 1050. Yes or no? This is the number 1050. It is divisible by 10 because the last number ends with 0 here. So this you need to understand. If you need to understand here, okay, last number ends with 5 or 0, then it is divisible by 5, or last number ends with 0, then it is divisible by 10 here. Okay, so what is the divisibility rule for number 2? Okay, number 2. So any number last digit is either even number or 0. Thus in a particular number the last digit is either even or 0, then that number is divisible by actually 2 here. Say for example 1652, even number is there here. Okay, so 1658, even number is there, or 1650, 0 is there here. So these 3 numbers will be divisible by 2 here. Okay, so for example, see, the next rule is 3 and 9. Which number goes with 3 and 9? What is the rule for digits 3 and 9 here? See here, when you add that sum of the digits, okay, there is a particular number. Okay, say for example 342. Okay, 342 is a number I am taking an example here. You need to add the individual digits, and the sum of that number, the sum of that digit should be either divisible by 3. Okay, should be divisible by 3. See, for example 342 is there, so 3 plus 4 7, 7 plus 2 is 9, so 9 we got here. Okay, this sum should be divisible by 3, then only that number, actually 342, it goes with 3 here. Okay, as well as 9. Okay, the same rule applies for 9 here. Okay, so you need to add the sum of the digit, this sum should be divisible by 3 or 9, then only the number will be divisible by 3 and 9 here. Okay friends, so the divisibility rule for 4 and 8. Okay, 4 and 8, actually it is similar to for 2. Okay, the divisibility rule of 2 is similar to 4 and 8, but what we need to consider is the last 2 digits of that number. Okay, the last 2 digits, the last 2 digits of that number should be divisible by 4, should be divisible by 4, then the complete number will be divisible by 4. Okay, so for 8, see, for 4 this is the rule here. Okay, so for 8 the last 3 digits you need to take here, last 3 digits of that particular number. Okay, last 3 digit, if at all it's divisible by 8, then the complete number is divisible by 8 here. Okay, simple. So for 6 I'll be taking now the rule for 6. So what is the divisibility rule of 6? See here, number is divisible by 6 if at all that particular number is divisible either by 2 and 3, not either 2 and 3. If at all the number is divisible by 2 and 3, that particular number will also be divisible by 6. Say for example, see here, 126. Okay, for divisible rule of 2 we know it should be even number here. Okay, so divisible by 2, yes. Okay, and then 3, 6 plus 2, 8, 8 plus 1, 9. So this 9, the sum is 9 here. Okay, so it is divisible by 3 as well, this 126. So if at all the two conditions are satisfied, then the number 126 is also divisible by 6, is also divisible by 6 here. Okay, simple, right? So what is the divisible rule for number 12 now? Number 12. Okay, see, the same conditions apply here. Okay, if at all that particular number is divisible by 3 and 4, then that number is divisible by 12 also. Okay, see, for example these table here. Okay, so 12 over, and 14 also the same case, and 15 also the same case, and 18 also the same case. Okay, these are easy to remember. Okay, see, if at all that number is either it should be divisible by both 7 and 2, then that number is also divisible by 14 as well. For 15 means 5 and 3. Okay, for 18 means 9 and 2, 9 and 2. Okay, then the number, that particular number is also will be divisible by 12, 14, 15, 18, it goes on like this. Okay, see friends, still here actually it was bit easy. Now I'll be dealing with few of the tougher concepts. Okay, if at all how we need to check the divisibility rule by 7 here. Okay, 7 here. See, what we need to do is, say for example 343 is there, we need to check whether this 343 is divisible by 7 or not. Okay, see here, the last digit I'll be taking. Okay, last digit means 3, so I need to multiply 3 with 2, I'll get the answer 6, right? Okay, this is the first step here. So what are the remaining numbers? They are 34. The remaining numbers are 34. Okay, so these remaining numbers I need to subtract with this number. Okay, 34 minus 6, how much I'll be getting? 28 I'll be getting. So we need to check this number. If it is divisible by 7, then that number is divisible by 7. Which number? The 343 number is there, no? That is divisible by 7. Okay, 7 4 times is 28. Yes or no? Hence 343 is divisible by 7 here. Okay, see friends, what you need to do, what you did here is, you need to take the last digit, you need to multiply it by 2. The last digit you need to multiply it by 2. 3 you multiplied by 2, you got the answer. So the remaining numbers will be 34. So 34 minus this answer, 34 minus 6, we got 28, and you need to check this 28 whether it is divisible by 7. Okay, then only the number is divisible by 7 here. Yes or no? If 4 digits are there, for example, see, if 4 digits are there, 343 was there, another number I'll add, 3343 are there. So then what you will do is, see, the last number you need to take 3, you multiply it by 2. 3 into 2, that will be 6 here. Okay, this 6 should be subtracted by the remaining numbers, 334 minus 6. Okay, that is nothing but 328. Okay, this you need to check whether if it is divisible by 7 or not. Then only it goes by 7 or not. Then only 3343 number will be divisible by 7. It goes on like this. Okay, so now the divisibility rule for 17. Okay, divisibility rule by 17 here. Okay, this I'll be dealing with now. Say for example, I'll take a number 1904. This number I need to check whether it is divisible by 7 or not. Okay, what I'll do is, see friends, actually this last number I'll be taking here. Okay, so last number I have taken, so I'm multiplying it by 5. Okay, this you need to remember here. So the product is 20 here. Okay, this product shall be subtracted with the remaining numbers, 190 minus 20. Okay, what the answer I am getting here is 170. If at all this number is divisible by 17, then the whole number will be divisible by 17. Okay, so this is the rule here. Okay, you need to multiply it with 5 and you need to subtract with the remaining numbers. That you need to understand here. Okay, so divisibility by 19. Okay, we need to check the rule for divisibility by 19 here. So what I'll do is, see for example, I'll take the number 361. Okay, so this last number I'll take 1. I am multiplying it with 2 here. So the product I got is 2 here. So what is the remaining numbers? Actually remaining numbers are 36. Okay, 36 I'll write here. In the earlier two case I subtracted, right? Now we need to add here. Okay, this you need to remember here, you need to take a caution here. Okay, earlier case you had subtracted, now you are adding here. So 38 we got here, right? So if at all this 38 is divided by 19, it goes by 19, then the whole number will be divisible by 19. Okay, so this is simple here. Okay, so the divisibility rule by for 13 now, divisibility rule for 13. Say for example, I'll take 325 number here. Okay, let us consider the example 325 here. So last number I am taking 5, I am taking, I am multiplying it with 4, so I am getting 20 here. Yes or no? I got 20 here, and the remaining numbers are 32. Here I am adding with this number 20. Okay, 32 plus 20, that is nothing but 52. Okay, I'll be checking this 52 whether it goes by 13 or not. If at all it goes with 13, then the number 325, it is divisible by 13, or else it is not here. Okay, this condition you need to remember here. For 13 and for 19 you need to add. For 13 and 19 you need to add here. Okay, so now divisibility rule of by 11. This is very important here to check the divisibility rule for 11 here. Say for example 9174 is the number here. Okay, so what you need to do is add odd digits and add even digits here. Okay, what are the odd digits here? See, these are the odd digits here. Okay, 9 and 7 are the odd digits, so 9 plus 7 here. Okay, so then 1 and 4 are the even digits, so 1 plus 4. So 9 plus 7 is 16. Then you need to subtract here. 1 plus 4 is 5 here. Okay, this condition you need to remember. 16 minus 5, how much we got? That is 11. Okay, if this number is divisible by 11, okay, that number, if at all it goes with 11, then the whole number 9174 number, it goes with the 11. This condition you need to remember. Say for example, see friends, I'll take one more examples. See, I'll check for 6392. 63915. Okay, let us take this number 63915. So what we need to do is we need to add the odd digits first. Okay, odd digit means 6, 9 and 5. Okay, so 6 plus 9 plus 5. Okay, what are the even digits? 3 and 1. Okay, you need to subtract here, so 3 plus 1. Okay, so 6 plus 9 plus 5, 9 plus 1 is 10, and 14 4 14, 14 plus 6 is 20 here. So 20 minus 4, that will be 16 here. Okay, 20 minus 4 is 16 here, yes or no? So if at all this 16, whether it goes by 11, no, it doesn't goes by 11. So hence the number 63915, it is not divisible by 11. Okay friends, these are the divisibility rules. If at all you remember while solving the problems, it will become easier for you. Okay friends, so let's go to the concepts now. The first concept will be finding the unit digit. Okay, in 2020 paper there were given there was a problem. See friends, actually 1 into 2 into 10 into 300 into some numbers were given, and they were asking how many zeros will be there. Okay, so in the same case the question will be like 936 plus 972 or 200 something plus 93 into 26. Some numbers will be given, and in the final product of that number, so what is the unit digit? So that kind of questions you will be expecting. So I'll try to explain how the concept works in the next page here. Okay, so finding the unit digit. So finding the unit digit. Okay, see friends, I'll take an example here. See, if at all they ask you to find the unit digit of 936 plus 972 plus 221. Okay, so after adding, what will be the unit digit here? Unit digit means actually these numbers, right? In these numbers, these are the unit digits here. Okay, so you need not add the whole problem here. Okay, you need not to solve the whole problem. 936 plus 972 and 221, they are only concerned about the unit digits. So what are the unit digits here? See here, 6 and 2 is there and 1 is there. Okay, only you need to add these numbers actually. See, 6 plus 2, 8 plus 1, 9 will be the product here. Okay, so in the final product, unit digit will be 9 here. Okay, it goes on like this. Okay, say one more example I'll take. 93 into 46. Okay, what are the unit digits here? 3 and 6 are the unit digits here. So 6 into 3 is 18 here, right? So 8 will be in the place of unit digit here. 8 will be in the place of unit digit here. Similarly, for example, say 7 cube. Yes or no? 7 into 7 into 7. Okay, this what will be the unit digit of this 7 cube here? So 7 into 7 is 49. Okay, so 49 into 7 you not need to multiply. Okay, so 9 into 7 you will be doing here. 9 into 7 is 63 here. Okay, so 3 will be the unit digit here. 3 will be the unit digit here. Simple, right? See friends, actually for the smaller number it will be easy to find out without any knowing the formula or method here. Okay, so for example, see here, I'll tell you, if at all the question appears 266 to the power of 13 plus 395 to the power of 45. Okay, so then it will be a tedious job to find out the unit place here. Okay, because 266 to the power of 13 is there and 395 to the power of 45 is there. So then it will become very difficulty here. Okay, so for to solve these kind of problem, there is a formula here. Okay, see here, you need to remember this. So what is that formula is, see, 0 to the power of n, that will be equals to 0. Okay, I'll explain you. See here, 1 to the power of n, that will be equals to 1. Okay, similarly 5 to the power of n, that will be equals to 5, and 6 to the power of n, that will be equals to 6. You need to remember this. 0 to the power of n will be 0, and 1 to the power of n will be 1, and 5 to the power of n will be 5, and 6 to the power of n will be 6. You need to remember this. See, I'll explain you through a problem here. Okay, say for example 26 to the power of 2. See the unit digit here, 6 is there, no? So 6 to the power of n will also be 6, means we are not concerned about this power. Okay, 6 to the power of any number, the unit digit will be 6 here. This is the rule here. Okay, say for example 2 to the power of 26 to the power of 142. So we are not concerned about this power here, we are only concerned about the unit digit here. So unit digit, so 6 to the power of n, it will also be 6 only. Got it, friends? So now this problem will solve here. Okay, 266 to the power of 13. Okay, see here, 266 to the power of 13 plus 395 to the power of 45. So friends, we know that 6 to the power of n is always 6 and 5 to the power of n is also 5 here. We know the rule right here. So here, see, 6 to the power of 13 is there. Okay, in the unit digit it will be 6 here, and 5 to the power of 45 is there. So 5 to the power of n is also 5 here. So 6 plus 5, it will become 11 here. Okay, the unit digit is 1 here. The unit digit is 1. Simple, right? Without any solving 266 to the power of 13, we are getting the formula. In the unit digit, the number will be 1 here. Simple, right? So one more example I'll take here. See friends, 2311, say to the power of 124. Okay, so into, so 646 into no, to the power of 94. See, by solving this problem, actually it becomes a very tedious method. See, you know the formula, right? See, 1 to the power of n will be equals to 1. Okay, 6 to the power of n will be equals to 6 here. So 1 to the power of 124, it might be anything, n can be anything here. So the unit digit will be 1. So into is here. Okay, 6 to the power of 94, 6 to the power of n is 6 here. So 6. So 6 into 1 is 6. The unit digit will be 6 here. Simple, right? So, okay, this is the first case here. These are the first case. You need to take a note of this and you need to remember here. Okay, so what kind of the second set I'll be dealing in the next page here. See friends, okay, the second set will be, say for example the number ends with 4 here. 4 to the power of odd number, 4 to the power of odd number is there, then the unit digit will be 4. Okay, and 4 to the power of even number, then the number will be 6 here. This is the rule you need to remember. 4 to the power of odd number means, say for example 254 to the power of 36. So 4 to the power of odd number or even number you need to check. So 4 is there, so the power of 36 is there. So 4 to the power of even number it is. 36 is an even number. So the unit digit will be 6 here. Okay, so this condition you need to remember. And see here also the same condition applies for this rule also. 9 to the power of odd number, then the unit digit will be 9 here. Okay, so 9 to the power of even number, then it will be 1 here. These two conditions you need to remember. 4 to the power of odd number and 4 to the power of even number, and 9 to the power of odd number and 9 to the power of even number. Say for example we solve a problem here. Okay, so say for example 249 to the power of 33 plus 254 to the power of 36 plus 256 to the power of 133. Okay, so 9 to the power of even number, odd number is there here. Okay, so 9 to the power of odd number is there. So plus 4 to the power of odd number is there. So plus 6 to the power of, so 133 is there. Okay, for 6 there is no condition, right? 6 to the power of n is always 6. That we know, that we learnt in the previous method here. 6 to the power of n will always be 6. So we will be solving this. So 9 to the power of odd number means it is 9. 4 to the power of odd number means, no, actually it is mistakenly I have written the odd. 4 to the power of even number it is. Okay, so make a note here. Mistakenly I wrote an odd here. So 4 to the power of even number is nothing but 6 here. Okay, 4 to the power of even number, 4 to the power of even number is there. So 6 will be here. So 9 plus 6 plus 6 to the power of n, that will be 6 here. Okay, we need to add here. So 9 plus 6, that is 12 plus 9, that will be 21 here. So unit digit will be 1 here. Okay, after solving this above equation, above problem here, see 249 to the power of 33, 254 to the power of 36 plus 256 to the power of 133. In the final solution, in the unit digit, 1 will be the answer here. Okay. See friends, till now what we solved is, we got the unit digit if at all the number ends with 0, or number ends with 1, or number ends with 5, or number ends with 6, or number ends with 4, or number ends with 9. Okay, if at all these are the conditions we solved here. Okay, if at all the number ends with either 2 or 3 or 7 or 8, in that condition, okay, what is the rule here that you will be that I'll be dealing with now here. Okay, see, 0 to the power of n, that will be 0. Okay, 1 to the power of n, that will be 1 here. 5 to the power of n, it will be 5. 6 to the power of n, it will be 6 here. So 4 to the power of odd number, then 4. 4 to the power of even number, then 6. So 9 to the power of odd number, then 9. 9 to the power of even number, then 1. Okay, these are the rules we had dealt with in the previous examples. Okay, see, if at all the number ends with 2, 3, 7 and 8, so what is the case here? What you need to do is, you need to divide the power. Okay, if at all, see, for examples, 212 whole to the power of 79, it is given here. Okay, what is the unit digit they are asking here? See, the number is ending with 2 here, yes or no? What you need to do is, this power is there, no, this 79, this you need to divide the power by 4 here. 79 divided by 4, and you need to find the remainder here. Remainder you need to find. See, the solving will be like this. Okay, 79 divided by 4, so 4 1 times, so 3 is remaining, 9 is there, so 4 9s are 36 here. Okay, 4 9s are 36, so 3 is the remainder here. Okay, we got the remainder as 3 here. Okay, so this 3 remainder is there, no, it is very important here. So what was the last digit? 2 is the last digit. Okay, so see here, this 2 was the last digit, you can see now 2 is the last digit, and remainder we got 3. So what we need to do is, the last digit to the power of this remainder you will be calculating. So 2 power 3 is 8 here. Okay, so this will be the answer here, 212 to the power of 79. If at all you solve this, in the unit digit you will be getting 8 here. So how I did, friends? Actually, if the number ends with 2, 3, 7, 8, then this power is there, no, this power, actually you need to divide this power by 4, and you need to find the remainder here. Okay, so then the last digit, either 2, 3, 7, 8, so that digit to the power of this remainder, 2 to the power of 3, that will be 8 here, and this will be the unit digit for that number. Okay, I'll take one more example. See friends, here, say for example, here only I'll be taking, see, consider 73 to the power of 54. Okay, the number ends with 3, right? So what you need to do is, this 54, no, you need to divide it by 4 here. So 4 1 times, so 1 is there, 14 is there, 4 3s are 12, so 2 is the remainder here. So what is the last digit here? So last digit is 3 to the power of 2, that will be 3 into 3 will be 9 here. So unit digit will be 9 here. 73 to the power of 54, the unit digit will be 9 here. So one more example I'll take here. See, 378 to the power of 41925. Okay, if at all the number is like this, find the unit digit of 378 to the power of 41925. So then what, the last digit is 8 here, right? So what you need to do is, 41925, you need to divide it by 4 here, yes or no? See friends, actually solving this again, it will be very much tedious, right? So one more trick is there, friends, don't worry. See here, 41925 is there, so last 2 digits you need to take here. Okay, so last 2 digits will be 25 here, so that you need to divide it by 4 here. Okay, so 4 6s are 24, so 1 is remaining, so remainder will be 1. So the last digit is 8 here, so 8 power 1, 8 power 1, that will be 8 here. So after solving 378 to the power of 41925, the unit digit will be 8 here. Simple, right? Okay, yes or no? So if at all remainder happens to be 0, this remainder, we got 1 here, right? If at all the remainder happens to be 0, then what you will do? Okay, Say for example, see 214 is there to the power of 2164. Okay, so 2164 is there, so last two digits will be taking here, that is 64. 64 I'll be taking divided by 4. 4 1 times 4, so 224 is there. 4 6 are 24, so the remainder happened to be 0 here. Okay, but the last digit is 4 here, right? So remainder, if at all it happens to be 0, then 4 to the power of 0, this will be wrong here, because 0 is here and last digit is here. So 4 to the power of 0, this will be wrong here. Okay, this caution you need to take here. So what you will be doing here is, instead you will be writing 4 because of the last digit, and which number you divided here, this number, which number you divided by 4, right? So 4 to the power of 4 you will be writing here. Okay, so 4 to the power of 4 is 4 into 4 into 4 into 4, so 4 4s are 16 and 4 4s are 16 here. Okay, so last digit will be 6 into 6, right? So 36 here, so 6 will be the answer here. Okay, unit digit will be the 6 here. Got it, right? Got it, friends? See, one more time I'll solve here for your reference sake. One more time I'll solve in a detailed manner. See here. So what was the number? 214 was the number to the power of 2164. Okay, so then what you will be doing here is 2164 you need to divide by 4, but because if it's a larger number, we'll be taking only last two digits here. So 64 divided by 4, so 4 1 times 2 is there, so 4 6 are 24 here, so 4 6 are 24, so the remainder is 0. In general case, what we were doing is, the last digit we were taking, that is 4, and 0 remainder we were taking, so 4 to the power of 0. This, if at all the remainder happens to be 0, this condition will not apply here. Okay, this conditions will not apply here. Instead what you will do is, the last digit you will be taking here, 4 was the last digit, and the number which divided here, okay, the 4 it was divided here, so 4 to the power of 4 will be taking here. Instead we will be taking 4 to the power of 4, so that will be 4 into 4 into 4 into 4, so 4 4s are 16, so 4 4s are 16. You need not to multiply 16 into 16, right? We are only concerned about the unit digit here. So 6 into 6, it will be 36 here, so unit digit will be 6 here. Got it, friends? Simple, right? So one example I'll take, and I'll solve it in the next page. See, if at all they ask you to find the unit digit of 124 to the power of 376 plus 124 to the power of 375, if at all they ask you to find the unit digit, what is the unit digit here? Yes or no? Then what you will do is, 4 to the power of even number is there, the condition 4 to the power of even number, okay, plus 4 to the power of odd number is here, 4 to the power of odd number is here. So 4 to the power of even number is nothing but 6, 4 to the power of odd number is nothing but 4. Okay, 4 to the power of odd number is 4, and 4 to the power of even number is 6 here, so 6 plus 4 is 10, so the unit digit will be 0 here. Simple, right? When you know the rule, friends, actually, then this solving this problem will be in only one method, only in one step. Okay, see, friends, actually in the next page I'll tell you how to convert decimals to fraction here. Okay, so decimal to fractions. So what is a decimal number actually? See, 0.12, it is a decimal number here. Okay, so 0.12 is there, so it is a decimal number. If at all the question asks you to convert 0.12 into fraction, what you will be doing is, so 0.12 upon 100. Okay, because two places are there, after 0.2 places are there, so you will be dividing it by 100. So this is the wrong format of writing. Actually, what is the right format of writing is 12 divided by 100. Okay, after taking this two powers to the right side, it will be 12 divided by 100. Okay, so after calculating, it will be looking like this. Okay, 12 divided by 100 is nothing but, actually it goes in 4 table. 4 3s are 12 and 4 2s are 8 so 2 is remaining, so 4 5s are 20, that is nothing but 3 by 25. Okay, so this is a fraction here. So we just converted, see here, we just converted 0.12 into, this was a decimal format, we converted it into 3 by 25 here. Okay, so this is the normal method using to convert a decimal into fraction method here. Okay, so what type of what different types of decimals there will be there? See here, type 1 will be actually 0.12. Okay, so type 2 will be 0.12 bar. Okay, so what is this bar representing here? Actually it represents here like this, so recurring digits. Okay, it represents recurring digits. 0.12 bar is nothing but 0.12 12 12, it goes on. Okay, so if at all a digit is recurring, then it is indicated with bar here. Okay, see for example 0.43 bar. Okay, then the digit 3 will be recurring here, 0.4333, it goes on like this. Okay, so this is the second type of decimal number here. Okay, so the third type will be actually a whole number and a decimal. So it will be example 5.21 bar. So how can we write this as 5.212121, it goes on recurring here. Okay, so this is indicated by bar here. So majorly these three types of decimals you will be encountering in the examination, friends. Okay, so how to solve this decimals into fraction? See here, I'll be writing here. Okay, I'll show you how to solve it. Okay, see for example say there is a number 0.4 bar is there. Okay, it is nothing but actually 0.444, it goes on recurring here. Okay, so what you need to do is to convert this decimal into fraction. See what is the number here indicated with the bar? 0.4 is there, so 4 you will write here. So to single number bar is there, so you are dividing it by 4 by 9. Okay, 0.4 bar is nothing but 4 by 9 here, you need to divide it by 9 here. So this rule you need to remember here. So I'll take one more example. See friends, if at all it is 0.93 bar is there. Okay, so what are the two digits here? 93 are the two digits here. So so for two numbers bar is represented here. Okay, so two numbers means 299 here. Okay, 9 and 9, so 93 by 99. Upon solving in three tables, so 3 3s are 3 1s are and 3 3s are, so it's nothing but 31 by 33. Got it friends? Simple, right? Similarly 0.631 bar is there. So what are the three numbers here? 631 are the three numbers here. So for three numbers bar is represented, so divided by 9 9 and 9. Okay, this condition, this is the type 1, this will be the type 1 decimal problems here. Okay, so for example, so what is the type 2 then? See if at all you encounter a problem 0.43 bar here. Okay, for single digit a bar is here. Okay, so to solve this, what you will do is take the last two digits, 43 you will be writing here. Okay, so what you need to do is 43, you need to subtract this 43 by some number. So what is that some number? Some number you need to subtract this 43. Okay, so see here guys, actually in 43 bar this 4 is not having bar here. Yes or no? Only 3 is having bar here. So this number you need to subtract with 43 here. Okay, so 43 minus 4 divided upon, for single number bar is there, so single 9 will be represented, and for single number bar is not there, so 0. Yes or no? So 43 minus 4 divided by 90 is the answer here. 0.43 bar, it can be represented as 43 minus 4 divided by 90. This will give you 43 minus 4 is nothing but 39 divided upon 90 here. Okay, upon solving 3 1 times, 3 3 times and 3 30 times, that will be 13 by 30. Okay, you converted 0.43 bar into fraction here. Got it friends? See one more example I'll be taking now. Say consider 0.48 bar is there. Okay, 0.48 bar is there. So what you will do, first step, you will take these two numbers, 48. So this number should be subtracted with some number. So what is that some number? So this 4 doesn't have bar here, so you are subtracting with that 4 here. You are substituting and subtracting this 48 with 4 here. Okay, upon, so one number bar is there. Okay, so 9 you'll write, and one number bar is not there, so 0 you'll write here. So 48 minus 4 upon 90, so it is nothing but 44 divided by 90. Okay, this is the fraction here. This was the decimal and this was the fraction here, guys. Okay, simple. So one more example I'll take here. See, 0.633 bar. Okay, so what are the three numbers here? 633 are the three numbers here. So this number you need to subtract with some number. So what is that some number? This 6 actually doesn't have bar, so 633 minus 6 upon two numbers are having bar here, so 9. Okay, and one number is not having bar here, so 0. Got it, friends? Simple, right? 633 minus 6 upon 990, so this will be 633 minus 6 is 627 upon 990. Upon solving this 0.633 bar, you will be converting this decimal is being converted into fraction here. Simple, right? So another type will be, see here in the next page I'll solve here. So what is the third type? Actually 5.21 bar is there. Okay, you need to convert this decimal into fraction. Okay, so what you will do is, see, how can we write this 5.21 bar? It can be written as 5 plus 0.21 bar. Yes or no, friends? It can be written like this, right? So for this 0.21 bar, we know the substitution here. Okay, so last two numbers I'll be taking 21, so 21 bar is there, so upon 99. Yes or no? So plus 5. Upon taking LCM and cross multiplying, I'll be getting as, see, LCM is 99, so 99 into 5 will be, so 5 nines are 45, 4 will be carry, 5 nines are 45, then so 45 plus 4 will be 49, so 495, so 495 plus 21, that will be 6 and 516 divided by 99. This is the answer here. Okay, you converted 5.21 bar into fraction here. Okay, similarly I'll take one more example. See here, friends, 2.12 bar. Okay, see, in this previous number two numbers was having bar here. In this problem actually the single number is having bar here, so you can split this, right? 2 plus 0.12 bar. Yes or no? This 12 bar, how can we substitute? See here, two numbers I'll be taking, the last two numbers are 12 minus what you need to subtract, this 1, so 12 minus 1 upon single number is having bar here, so and another number is not having bar. Simple, right? So plus 2. So simple, right? 12 minus 1 divided by 90, so 12 minus 1 is nothing but 11 by 90 plus 2, so LCM will be 90. So 9 2s are 18, so 180 plus 11, so 180 plus 10 is 190, so 191 by 90. Yes or no? 191 by 90 is the answer here. So this is the way you will be converting decimals to fraction, friends. Okay, this was the concepts regarding how to convert a decimal into fraction, friends. In the next concept I'll be dealing with sum of the series here. Okay, so sum of the series. See, if at all you encounter a question, see for example 1 plus 2 plus 3 plus, it goes on till 100. So what is the sum of this series? If at all question asks you to find the sum of this series, so how you will find? In actually traditional methods also, 1 plus 2 is 3 and 3 plus 3 is 6 and 6 plus 4 is 10. It goes on like this. So this is the tedious job, right? So there is a formula for this, friends, actually. Okay, so what is the formula? N into n plus 1 upon 2. This is the formula here. So what is n here? The last digit is n here. Okay, so for example say 1 plus 2 plus 3 plus, it goes on till 30. Okay, so what is the sum of this series? If at all you encounter a question like this, so you know the formula, right? So n into n plus 1 upon 2, this is the formula, you know. So what is in here? The last number is in here. Okay, so 30 into 30 plus 1 upon 2. Okay, 30 plus 1, 30 into 31, 30 into 31 upon 2, so 2 1 times and 2 15 times, so 15 into 31, so 465 is the answer, friends. Okay, simple, right? So if at all you encounter a problem in this format, so 1 plus 2 plus 3 to any n number. So this is the formula here. So there is a second type, friends. If at all you encounter a question, see like this. If at all you encounter a question, see 1 square plus 2 square plus 3 square, it goes on till n square. What is the sum of this series? So then the formula will be n into n plus 1 into 2n plus 1 upon 6 here. This is the formula you need to remember here. Okay, for 1 square plus 2 square plus 3 square till n square. So this is the formula here. Okay, so what do you mean by n? This is the last number. If at all you encounter a problem like this, 1 cube plus 2 cube plus 3 cube plus it goes on till n cube. So what is the formula here? It is actually n into n plus 1 divided by 2 to the whole square. This is the formula, guys. Okay, this formula you need to remember here. Okay, see this formula actually for 1 plus 2 plus 3 whole to the power of plus n, the formula is n into n plus 1 upon 2. Okay, so for this formula, that is 1 cube plus 2 cube plus 3 cube, the formula is same, but what you need to do is you need to square here. Okay, so for 1 square, 2 square, 3 square, it is n into n plus 1 into 2n plus 1 upon 6 here. Okay, so actually the formula goes on, right? Okay, 1 to the power of 4, 2 to the power of 4, actually it goes on. But for this examination sake, if at all you remember these three formulas, that is n into n plus 1 upon 2, this one formula, and n into n plus 1 into 2n plus 1 upon 6, and n into n plus 1 upon 2 to the power of whole square. If at all you remember these three formulas, it is more than sufficient, friends. Okay, try to memorize these formulas. Without memorizing these formulas, it will be very much difficult to arrive to the solution, friends. Okay, see, this was the these were the three different types, and another two types are there. See here, I'll be dealing with now. Another two types of problems are, if at all questions ask you to find the sum of odd numbers. Okay, sum of odd numbers. Okay, what are the odd numbers? If, say for example 1 plus 3 plus 5, it goes on like this, right? If at all question asks you to find the sum of odd number, then the formula is x square. Simple, the formula is x square. So what is this x? Actually this x is nothing but n plus 1 by 2. Okay, this n is the last number here. Okay, say for example the question says 1 plus 3 plus 5 plus it goes on till 33. Okay, if at all the question is like this, 1 plus 3 plus 5, it goes on till 33, then the formula is x square. Okay, so what is this x? X is nothing but n plus 1 divided by 2. What is this n? This is the last number, that is 33. So 33 plus 1 divided by 2. So 33 plus 1 is 34 upon 2. So 2 1 times and 2 17 times. Okay, so we got x is equals to 17 here. So what is the formula? It is x square. So 17 square. So 17 into 17. So it is nothing but 7 sevens are 49, and 4 is coming. 7 is a 7. 11 will be there. Okay, and 1 7 is a 7 plus 1 1 is a 1. So it will be 289. Okay, so the sum of this odd number series will be 289, friends. Okay, similarly, if at all you encounter a problem based upon even number, okay, then the formula is nothing but x into x plus 1. Okay, x into x plus 1. This is the formula you need to remember if at all the question asks you to find the series of even number. So x into x plus n. So what is x here? X will be n divided by 2 here. Okay, simple, right? So here I will be writing, see friends, here actually for odd series, what is the formula here? X square. Simple formula, right? X square. So what is this x? X is nothing but n plus 1 upon 2. Okay, so n is the last digit here. So for even series, it is actually, for even series, it is x into x plus 1. So this is the formula here. Okay, So x into x plus 1. So what is x here? X is nothing but n divided by 2 here. Yes or no? So these you need to remember if at all the question asks you to find the sum of the series here. Okay friends. So moving on to the next concept. So the next concept is finding the remainder. Finding the remainder, friends. Okay. So this is the last topic for today's class here. Finding the remainder here. So if at all, see, question asks you to find a fraction, they will give a fraction 23 upon find, and if at all they ask you to find the remainder, what you will do is 5 into 23 you will be writing here. So 5 4s are 20, so remainder is 3 here. So this is the basic type how we will be solving the problem here. Okay, see, if at all the question asks like this, 86 into 23 divided by 11, so then what you will do is individually divide here 86 by 11 into 23 divided by 11. So okay, you need not do like this, friends. Here 11 into 86, you know, you need not do this calculation, you can do in mind only. So 11 1 times and 11 7 times. 11 7 times means 77. So 77 to 86 minus 77 will be 9 here. So remainder is 9 here. So 11 1 times and 11 2 times 22. So 23 minus 22 is 1 here. Okay, so remainder will be 1 here. So the calculation will be here 86 into 23 upon 11 is given. So remainder we got 9 here and remainder we got 1 here. So in between multiplication symbol is there. So 9 into 1 is nothing but 9 will be the remainder, friends. Okay, simple, right? So one more example I'll take here. See friends, actually what will happen is 38 plus 71 plus 86 upon 16. If at all the question comes like this, individually you will calculate here. Okay, so 38 by 16. Okay, 16 1 times and 16 2 times. 16 2s are, it is 32. So 38 minus 32 will be, remainder will be 6 here. Okay, so 71 upon 16. Okay, it goes with 16 1 times and 16 4 times, and remainder will be 7 here. Okay, and 86 is given. So 86 upon 16. So 16 1 times and 16 5 times. Okay, remainder will be, so 80 and 86 minus 80 will be 6 here. Remainder will be 6 here. So all three remainders we got here, right? 6 7 and 6. Okay, what you need to do is, so you need to add here 6 plus 7 plus 6 upon 16 will be getting here. Okay, so this 16 you can neglect here. Okay, so you need to add here 6 plus 6 is 12 and 12 plus 7 is 19 here. Okay, so the total remainder will be 19 when you work upon this problem here. Okay, so the total remainder will be 19. And one caution you need to take here, friends. What is that caution? See here, whenever you divide here, okay, see, observe this phenomena how it works here. Whenever you divide this remainder is there, no friends, actually this remainder, it will be always small. Okay, remainder should always be small when compared to this denominator here. Yes or no? This was the first problem I worked out. So this remainder is small when compared to the denominator. And see, for the second problem, 11 is in the denominator and remainder what I got is 9. So this remainder is smaller than this denominator here. Okay, so in third problem actually 16 is the condition here, right? 16 is the denominator here and remainder I got is 19 here. Okay, this condition doesn't satisfy. Okay, because 19 is greater than 16 here. Yes or no? So then what you will do? Okay, then what you will do is, if remainder it should be low with respect to the denominator, so the remainder here is 19 and this denominator is 16. Yes or no? So then what you will do is, you need to divide remainder upon again with denominator here, 19 by 16 here. So 16 in 1 times, so the remainder will be 3 here, friends. Okay, this condition you need to remember here, friends. Okay, simple, right? Yes or no? Very much simple. If at all the question asks you like this here, okay, 7 to the power of 5 whole divided by 4, what is the remainder? What is the remainder? If at all question asks you like this, so what is the expansion of this? 7 into 7 into 7 into 7 into 7 whole divided by 4. So you need to find the remainder here. Okay, so take individually. Okay, So take individually is nothing but, see, 7 upon 4, it will be 4 one times and the remainder is 3 here. Okay, for each case the remainder is 3 here. So 3 into 3 into 3 into 3 into 3. Okay, so this will be the total remainder here. See, when this remainder exceeds this denominator, what you will do is, obviously it will be exceeding here, right? So see here friends, actually 3 into 3 is 9 and 3 into 3 is 9 and 3. So 9 into 9 into 3. So it will be exceeding, right? So then what you will do is, so again 9 into 9 into 3, you will be subtracting with this 4, you will be dividing this by 4 here. Okay, so individually again divide 9 by 4 now. Okay, 9 by 4, so 4 one times and 4 two times, remainder is 1 here, and 9 by 4, so remainder will be 1 here, remainder will be 1 here, and 3 by 4, see friends, it cannot be divided by, right? So you will be keeping 3 as it is. So see what you will get is, see here, 9 into 9 into 3 upon 4, the for 9 by 4 you got remainder 1 into 9 by 4 you got remainder 1 into, you are keeping 3 as it is. Okay, so the total remainder will be 3 here. So what is the total remainder for this question? 7 to the power of 5 upon 4, the total remainder is 3 here friends. Okay, so when you solve multiple problems, you'll be facing it, you'll be feeling it as easy here. Okay, so if at all you don't understand, pause the video, again rewatch the video, then only you'll get a clarity friends. Okay, so this was the few of the basic concepts for before you solve the attempt the questions based upon number system friends. So thank you. Hope you find this video informative. So kindly do like, share and comment and subscribe to our AKKA IAS Academy channel. In the next 3 videos, I'll be dealing with few of the basic questions which you may encounter in the examination friends. Okay, in the next upcoming 3 videos there will be no explanation, because the 3 videos will be based upon number systems only. So for these 3 videos only, this was the biggest explanation guys. So in the next 3 videos I'll be dealing with the problems based upon number system. Thank you, God bless you all. Hope your preparation is going well. All the best friends. Catch you up in the next video. Thank you, God bless you all.